Okay, hello everyone. Thank you for coming to my talk. If you have any questions after the presentation, I'd love to talk to you. So if you think of a question underway, keep that in mind and just come up after or simply find me during the next couple of days here at the conference. Also, there's been a workshop on implementing passkeys here at NDC today, actually, which is very cool. I'm, however, not going to focus as much on how to implement passkeys, and instead I'm going to be focusing on the story of how we at BankID implemented passkeys and the numerous challenges we faced along the way. So that workshop and this presentation actually complement each other quite nicely. So anyway, my name is Tarald Riise. I'm a full-stack developer at Stø, which is the company behind products such as BankID. And I'm part of the team that works on the product informally known as BankID with biometrics. So I'm here to tell you about passwordless BankID using WebAuthn and passkeys. But before I do that, I need to put it in context of something else, and that else is regular BankID. And if you don't know what BankID is, welcome to Norway. It's very nice to have you. Be sure to enjoy the fjords and taste the brunost. And I can confidently assume that because as this chart shows, everywhere, okay, only 2% of the Norwegian population does not have a BankID where their age is not the reason why they don't yet have a BankID. So it is ubiquitous in Norwegian society. Now, BankID is an electronic ID solution, so you can identify yourself on the World Wide Web. It uses two-factor authentication, where you can either use the BankID app, a dedicated hardware code device, or your SIM card as the OTP code generator, which is the first factor. And then you have a second factor, which is something password-like, such as a password or a PIN. But actually, the SIM-based OTP named BankID Mobile was decommissioned 6 months ago. Rest in peace. And that means that if you still have a valid BankID today, you also have a BankID password. And I just need to emphasize, despite this talk containing the phrase passwordless BankID, BankID with a password is still very much a thing, and the password isn't entirely going away anytime soon. Moving on, BankID was launched in 2004, making it as old as Google Mail, World of Warcraft, and of course, Shrek 2. BankID is accepted by the Norwegian government as a valid eID solution, meaning you can use it to access digital services provided by the Norwegian government, such as booking a doctor's appointment online, filing your taxes, changing your name, divorcing, as well as being widely used in the private sector. BankID was started as a joint initiative by the Norwegian banks. Why would you have all the banks solving the same problem of authenticating customers when you can instead cooperate, save costs, and have a better product at the end of the day? It's also very convenient for the customers since they can use a single eID to log into all the banks and online services. And it makes it simpler for customers to change banks or be customer of multiple banks at the same time. And BankID is currently issued by the banks themselves, which means that you need to be a customer of a Norwegian bank in order to get your BankID. And the strictest banks require you to be at least 15 years of age to get your first BankID. Some require you to be 12, some 13, but the strictest 15. Hence the pie slice earlier for those under 15. And because you need to be a customer of a Norwegian bank to get your BankID, and there are people who aren't able to become customers of Norwegian banks, for example, because they lack the necessary paperwork, there are people who want a BankID but who simply cannot get one. And we as an organization are actively working to solve this. So that's BankID in general. Now let's talk about going passwordless, and more specifically, passwordless BankID with passkeys and WebAuthn. But before we look at the tech, I want to briefly touch on why. Why go passwordless? Well, it's simple, really. Passwords are problematic. And don't get me wrong, passwords have and continue to be a very important piece in the authentication space, and they aren't totally going away anytime soon, as I mentioned, but they aren't without problems either, as they are often relatively slow to enter, especially on mobile keyboards. Remember I said that the SIM-based OTP was decommissioned half a year ago, along with using a PIN instead of a password. Well, one of the most common complaints from the users who were negative to decommissioning that service was that it takes so long for them to enter their passwords on their mobile keyboards. So this is actually a real issue for our users. But there are other argumentatively more important issues with passwords. Passwords are often bad, meaning they're allowed to be low entropy. For example, this password, 1 through 8, isn't allowed by Google. It's not strong enough. And neither is this, replacing the last number with the A character, but introduce a special character, and now, according to Google, you have a strong password. Now, there's definitely an argument here that when it comes to selecting passwords, people are responsible for their own security. But we know from password research based on password breaches and leaks, and some here will even know from personal experience, that some people choose their passwords like this, thinking, what is the minimum amount of effort I can put into securing my account? And that naturally results in bad passwords. In fact, after I made this slide, I was kind of curious, is this a common password? 251 observations from breaches and leaks. So not very common, but not unique either, and passwords should hopefully be unique. Of course, there are worse passwords. So this password 1 through 6 has 42 million observations. And my point is here, some people will choose terrible passwords if they are allowed. And you can argue that passwords aren't what's bad necessarily, but rather that people are bad at selecting them. And that's a fair argument, but it doesn't really help your parents or your grandma or somebody else inclined to select a bad password. Because everybody participating in digital society today uses some form of password, and not everybody is good at selecting them. And rule-based approaches to password strength, as I showed you, it only takes you so far. Moving on, passwords are reused. So this password is, of course, from the classic XKCD comp trip on selecting a secure password. The argument is that you can construct a secure password from just a random sentence, and it will generally have higher entropy and therefore be more secure than other hard-to-remember passwords. And that's probably generally correct, but not if you reuse the exact password from that comic strip, right? Random being a keyword. Now, in the comic strip, this sentence was actually presented as an alternative to a typical hard-to-remember password, such as this one, Troubadour. But apparently, some actually preferred this password instead. Now, these examples are totally anecdotal, of course, and reusing passwords you have seen online is hopefully rare. The main worry in terms of password reuse is, of course, people reusing their own password across different accounts and application, leading to a single point of failure across multiple accounts. And we know this happens a lot. But on the point of hard-to-remember passwords, such as this one, passwords are often hard to remember and therefore often forgotten. Now, in my experience, it's an occupational hazard having to help elderly family members reset their forgotten passwords. Now, many of you are probably thinking, password managers, they fix all of these problems. And of course, you're right. But grandma isn't necessarily going to learn to use a password manager, and even if she did, passwords are still phishable, meaning they can be stolen. You can be tricked into giving yours away. For example, in this instance, 400 victims of BankID fraud. So in this particular case, perpetrators would monitor listings for used cars online at FIDO, and when they saw that a car was sold, was no longer for sale, they sent the seller a spoofed SMS appearing to be from the Norwegian version of the DMV by Vesna, telling the victim that they needed to sign some paperwork online regarding their recent car sale, together with a link. Once the victim clicked the link, they were served a phishing site on which they were asked for their BankID details, and once they entered their BankID details, they were subjected to an adversary in the middle attack and had their bank accounts emptied. And these 400 people aren't necessarily tech illiterate elderly, right? Most of them are probably well aware of the risks of phishing, and they were still phished. There's a property of passwords which makes them phishable, and that property is being communicable. You can tell somebody your password. You can send someone your password. Your password can be shared, and it can be copied, it can be logged, and it can be stored in plain text in a database somewhere, and it can generally just end outside of your control. So in summary, passwords are problematic, but for a long time, even with their faults, they were the best and most user-friendly option available for the general public. But now, there is a serious alternative. Passwordless. Just get rid of the password, right? And I know some of you are probably very skeptical right now. You're thinking to yourself, passwordless, is it just somebody else's password, but in the cloud? And you'll be right to be skeptical, but that's the thinking behind serverless. No, passwordless isn't a misnomer like serverless. We do actually remove the password. So let's look at the normal auth equation containing an identifier such as a username and a password. If you have both, you have access. We want to remove the password, so let's just do it. Oh no, this is bad, this is really bad, right? Of course, we need something to replace the password, so let's insert some made-up generic credential instead. Okay, so that's better. But since this is just me making things up anyway, let's embed the identifier inside the credential, so the user doesn't have to input the identifier when trying to authenticate. And this looks good, right? A credential gives you access. This makes sense as a mental model, like right here. But you may now be thinking, this looks familiar in technology. And you'd be right. This looks like something from public key cryptography. You have a private key, and the server has the corresponding public key, and being able to sign a random challenge from the server such that the result is verifiable by the server using the corresponding public key, that gives access. Now, if you're worried that this talk is going to devolve into a crypto talk, don't be. We will leave it at this. A private key gives you access. Now, in terms of achieving passwordless, is this really all we need, public key crypto, that we've had since 1973? Well, not quite, because where would you store this private key? In your file system? How do you use it to log into a website? Do you sign a login challenge from the server using OpenPGP and paste that result into an input field and form and send it? Of course not, because that would be a terrible user experience. Right? How do you protect this private key? Do you protect it with a password? No, obviously not, because that's what we're trying to avoid, right? So what about instead putting it inside a secure part of your phone or computer protected by biometrics, for example? And that sounds okay, but we still need to solve how to use it from a website. So we obviously need something more here, something new. And it should work everywhere, on Windows, macOS, Linux, iOS, and Android, because that's where all the users are. And it should preferably work without having to install a dedicated passwordless app. And it should obviously be secure and user-friendly. And if you want all of these nice things, you need a bunch of different technology organizations and companies to agree on the minute details of a new technology. And as far as I know, there is only one way to do that. That is a standards body. Yes. As you probably understood by now, there is a standards body for this technology we're searching for, and it's called the FIDO Alliance. And FIDO is an abbreviation for Fast Identity Online. And it is an open industry association to develop standards for passwordless authentication. And by the way, this isn't some small initiative by a few security enthusiasts. The FIDO Alliance has a huge backing from many big tech players. So these are the board level members of the Alliance. So notice that you can see all of the old FANG companies here, except for Netflix. Just let you look a bit while I have a sip. And here are some of the sponsor level members of the Alliance. So I couldn't fit them all here because there were 2 pages, so these are the ones above the fold. Note Netflix near the bottom, so that's all the FANG companies. And actually, if you look up to the right, there's us. Yeah. So a big initiative. Anyway, the FIDO Alliance developed standards, and they published 3 sets of specifications for simpler, stronger user authentication. So I won't go into the first 2, but the third, the set of client-to-authenticator protocols, abbreviated CTAP, is central to enable our passwordless experience, and especially the second version of CTAP, CTAP 2. Now, what CTAP 2 does is allow clients, such as operating systems, browsers, and native applications, a standardized way to communicate with platform authenticators, such as Windows Hello, Android Key Store, and Secure Enclave on iOS. Now, by allowing this communication, the clients can access the authentication capabilities already available on these devices. CTAP 2 also provides clients the means to communicate with roaming authenticators, meaning cross-platform portable authenticators such as YubiKeys, Google Titan security keys, and Phaeton security keys. So with CTAP 2, clients and authenticators have a protocol they can use to communicate. But giving these types of clients access to authenticators over a known protocol is just part of the solution here, because the website you want to log into, it isn't an operating system, it isn't a browser, and it's not really a native application, in this example at least. It's a website. So in order for a website to use CTAP2 to communicate with the authenticator, you need a standardized piece of web technology as well. And that standard is named WebAuthn. And WebAuthn, short for web authentication, is the counterpart to CTAP2, meaning it's the other core part of the FIDO2 set of specifications. Now, the FIDO Alliance submitted the FIDO2 specification to W3C, which is the International Standards Organization for the World Wide Web, and they did this in 2015 and worked from within the W3C to finalize the WebAuthn API. And as a result, WebAuthn was officially recognized as a W3C web standard in March of 2019. And now, combining CTAP2 and WebAuthn, we can get what we have been searching for, a credential which allows us to go passwordless on the web. And it is called a FIDO2 public key credential. Really rolls off the tongue, doesn't it? Awesome. Okay, how do we use it? To use a FIDO2 public key credential, you first have to create it. And to create it, we call navigator credentials create. And you call this from the browser. So this is the JavaScript API specified by WebAuthn. This will make the browser talk to your authenticator over CTAP2 and have the authenticator create a private public-private key pair, where the private key is kept in the authenticator to enable signing things, and the public key is sent to the server and persisted there in order to enable the server to verify signatures made by the corresponding private key at a later time. So the server will usually also associate the public key with some user identifier, such as an email address or a username or a national identity number, and store that together with the public key. And this will allow you to be identified by the server when using this credential. We also get some metadata back from this call, and depending upon what kind of security requirements you have, you can either ignore this metadata completely, or you can use it to verify the security characteristics of the authenticator which created this key pair. This is a legit authenticator. It is produced by Apple or Android or someone, right? Okay. So we will get back to this metadata later. Once you have created the key pair, you can use it to authenticate by calling navigator credentials get. This will make the browser talk to the authenticator over CTAP2. The authenticator looks for the private key, and if it's there, the authenticator asks the user for consent. Now, depending on the options provided by the websites when creating the credentials, this consent can either be a simple confirmation button, like tap to confirm, which just ensures there's somebody on the other side of the screen trying to authenticate, known as a user presence requirement, or it can be a stricter requirement, where the authenticator must also assert who is giving consent on the other side of the screen. And this is called user verification requirement. Now, regardless of which of these consent requirements are used, the result should be that automated attacks or zero-click attacks should be near impossible to perform. Of course, that's a statement made with reservations, but requiring some non-automatable physical user input is probably a really good idea in terms of security. All right, just have a sip. I'm talking a bit fast, I think you know. So once consent has been established according to the credentials requirements, we can sign a message using that private key. The server can then validate that signature against the public key it received during credential creation. And if it's a match, the server knows that you're holding the same private key from when you created the key pair. And that should hopefully mean that you're the same person, or someone else has gotten a hold of your authenticator and passed the consent requirement. So you've just authenticated a user on the web, and there wasn't any password involved. So if you ask me, this is pretty cool. It's easy, it's convenient, you don't have to type your password, and you don't have to remember anything other than to bring your authenticator, which is likely already on your device, right? But there's also another property of these credentials, which is a pretty big deal. the credentials are domain bound, meaning that if you create a credential on the domain bankid.no, you can only access that credential from bankid.no. This is enforced by the browser. This property basically makes these credentials unphishable. We thought this was cool and useful and convenient, and so we made a new BankID using this technology. And to our partners and those integrating with BankID, we've been calling it BankID with biometrics. To end users, it's marketed as faster BankID with face, finger, or PIN identification, which doesn't necessarily roll off the tongue either, but you'll see that is more accurate, but BankID with biometrics, yeah, rolls a bit better off the tongue, and we tend to use that for like non-user facing communications like this. And now that I've told you about the tech, I want to show you the tech. So I'm going to show you a sign up first. So this is where we create the credential. So somewhere inside the BankID app, I mentioned we have an app, there's a button saying something along the lines of, I want to start using faster BankID or something like that. And if I click that button, the BankID app will launch a Chrome custom tab, which effectively embeds a website inside the native app, which will allow us to use WebAuthn, which is a web API, inside the native app. Let me show you. So this is a web page, which is embedded into a native app. And this is on Android, by the way, but the principle is the same on iOS. And when I click this I understand button on the bottom there, pay close attention, you briefly, very briefly, just saw a loading bar appear, and then the screen went black. Oops. No, of course, the screen doesn't really go black. This is the operating system hiding the screen from my screen recorder because we just called navigator credentials create. And that is a secure operation, and my phone thinks this should not be recorded, which is probably wise. So what I'm actually seeing is something like this. And this is the platform authenticator on my Android device asking me to authenticate. And that's because we sent in the user verification requirements as an option when we call navigator credentials create. And this is an important point. The authenticator will select authentication methods based from what methods are already available from the authenticator. Meaning that if you have a totally unsecured device, no fingerprint, no PIN, no face, no pattern, no nothing, the authenticator has nothing it can use to protect the FIDO2 credential, so the credential creation will just fail. This also means that we don't need to register new biometric data on credential creation. Assume you have any kind of protection, right? Because this authenticator already has my fingerprint from when I enabled my screen lock. Now, this ceremony is entirely delegated to the authenticator, and the authenticator is responsible for storing and verifying the biometric data, meaning we don't have to store biometric data ourselves. Now, on this device, I have fingerprint authentication enabled, so it offers me to use that. I put my finger on the fingerprint, and we've just created a FIDO2 credential. And it's stored in the authenticator on this Android device from yesterday. I paused the video here, and what's going to happen now is that I'm going to be asked to sign an agreement to use BankID with biometrics. And we sign the agreement using our regular BankID with a password. We have a very bad password coming in right now, but it's just for test users, so it shouldn't matter. Great, and we're done. So what's neat here is that you sign the agreement using your regular BankID, which means that during this process, we were able to link your regular BankID identity to the FIDO2 credential you just created. So now you can use that FIDO2 credential, which doesn't require a password, instead of your regular BankID on websites and services which support that. Yes, once. The question was, I just entered my password. That is correct. So I entered my password once just to prove who I was and to bind my BankID identity with a password to the FIDO credential I just created.
So it's not gone?
No, it's not gone. It's an additional, it's like an extension service. Yeah.
But the password is not gone?
No, you still have your BankID password in your normal BankID, so this is like an extension.
So if it's a really bad BankID password, you can steal mine?
Yeah, so the question is if you still have your BankID password, somebody can steal that. Yes, but the more services that support passkeys and WebAuthn, the less you will ever use that password. Perhaps you just want to use that password when you're taking up a loan, like a homeowner's loan for many millions of kroners. Then it makes sense to use a password. But generally, for simple things, you shouldn't need your password is the idea. So you should think twice about entering your BankID password. So this is another question?
How do you deal with downgrade attacks? As you pointed out, if you have a password, you can use it. So what an attacker will do is they will try to downgrade your security by having you use something less secure, like a password way of getting in, which they can phish.
Yeah, so the question is, are we worried about downgrade attacks? How do we prevent that? Maybe we have time to talk a little bit about that at the end, but generally, the more times you can use passkeys, the less times you have to use your passwords, and you will probably have to think a bit more before you enter your passwords willy-nilly. There's one more question.
Yes, sorry, just read also something related. In the future, are you thinking like removing the password itself, or will continue?
Yes, so the question is, will we eventually remove the password? There's no concrete plans for that just now, but it's not impossible at some point, right? But we will just wait to see. Like right now, we're still trying to get 100% adoption. We're not quite there, but I'm going to tell you later how far we come. Okay, so we just linked our normal BankID user, normal BankID identity, to this passkey, and now we can use the passkey instead of our normal BankID with a password. Okay, so now we have created a FIDO2 credential. Let's see how we use it. Say you wanted to log into a website, and this website has a BankID integration, which has enabled BankID with biometrics. The first thing that happens after clicking the Login with BankID button is that we present what we call a context. What are you trying to do with your BankID? Are you trying to log in? Are you trying to transfer money? Now, at first glance, this context doesn't initially appear to be relevant to today's topic, right? As we're talking about authentication, and we haven't really authenticated. What's this screen about? But this screen actually serves a very important purpose with regards to adhering to the WebAuthn specification. Remember that consent I talked about? So in addition to the consent being enforced by the authenticator, it is also enforced by the browser, meaning the browser will not allow you to call navigator credentials get without that call being made as the result of some user action on this domain. For example, a button click. Now there's a button, and clicking that button calls navigator credentials get, which will now prompt us for biometrics. Recall being prompted for biometrics is a result of us enabling the user verification requirement as opposed to just the user presence requirement when creating the FIDO2 credential. Now, the exact form of verification will depend upon your device's capabilities, and you can be prompted for facial recognition, which means Face ID on iOS, or on Android. Face recognition with FIDO2 is currently only available, I believe, on a few select Google Pixel models, and that's because those are the only models with Class 3 biometric facial recognition support. Other authentication methods include fingerprint recognition, which is the one we're prompted for here. We can also be prompted for a screen lock pattern, which is only relevant, I believe, on Android devices. Note that the colloquial name kind of fell apart just now because a screen lock isn't technically biometrics. Anyway, you can also authenticate using a PIN, which is the fallback for Touch ID and Face ID on iOS, and it can also be enabled on Android instead of the screen lock pattern. So to summarize, there's different ways to authenticate locally against a FIDO2 credential, and it depends upon what's already available from the authenticator. Continuing with the demo, we provide the biometrics, and we're done. No password. Now, let me just show you one more time without me interrupting all the time. Pretty smooth, right? Smoother than having to confirm in the app and then enter your password, which is how you would likely normally authenticate with BankID. So FIDO2, it works, this product works, and you can now use a passwordless BankID with biometrics straight from the browser. Or can you? The question is, how do we save the fingerprints? We don't, so this is entirely delegated to authenticate the authenticator. So for example, on my device, I have a fingerprint. So this phone has my fingerprint in its authenticator. So that's just what we're using. So we're delegating the security to the phone. So the question is, what if the phone is stolen or lost? So screen locks are usually hard to get into unless your PIN is 1234. So that should probably, yeah, that's the reason, yeah. So the question is, how about passkeys being stolen? So passkeys are stored in the Secure Enclave on iOS and Android Key Store on Android, and those are supposed to be like tamper-proof. So it's very hard to extract private keys from that question.
Lost was mentioned.
Yeah.
If you lose your phone, then you lose the passkey, because that is the passkey.
Question is, if you lose your phone, do you lose the passkey? That is correct. Yes.
So without a password login, then you can't actually recover without going to a bank and identifying.
So the point is, if you don't then have a password, you can't recover. That's correct, which is why I'm saying like the password isn't going away anytime soon. So you need some kind of alternative authentication mechanism. That could be anything. That could be real, like biometrics, for example. You can scan your passport. There's lots of ways to do this. But yeah, so we have some strategies going forward. So yeah. Anyway, as I was saying, you can use. Yeah, another question. Yeah. So the question is the BankID app going to be the only passkey provider you allow? That's a very good question. I'm going to touch on that in a bit. I don't actually have an answer for you just now. Things can change, but yeah, I'm going to go ahead and you'll see what I mean. Okay. So, okay, sure. Can you have two different devices? Very good question. I'll also touch on that. So I'll just continue going and we'll do more questions at the end. Okay, so you can use the keys from your browser, or can you? Now, I've been talking all of this time like none of you are familiar with this product, but more probable than not, at least 3/4 of the Norwegian people here in this room have already signed up and are using this product, right? And according to our data, more than 60% of signups are from iPhones. So there's a bunch of Norwegian iPhone users here who noticed and know that you can't use your passwordless BankID directly from the browser on an iPhone. You have to go via the BankID app. And that's because something interesting happened to this product on iOS. Yes, this isn't only a story about what standards bodies can achieve when working together, it is also a drama. As I mentioned, WebAuthn became an official W3C spec in 2019. Development of BankID with biometrics started in November 2020. We set our launch target as September 22. But the summer of 2022, 2 weeks before our launch, Apple held their Apple Worldwide Developers Conference. And during that conference, Apple dropped a beta release of iOS 16, which introduced 2 changes which were relevant to us, one of which turned out to be very important. The first one was that Apple started referring to FIDO2 public key credentials as passkeys, which I agree is a more consumer-friendly term than FIDO2 public key credentials, right? So well done, Apple. That's definitely an improvement. But the second one, they also made these credentials syncable, meaning that the private key the authenticator created can be uploaded to iCloud and downloaded to other iOS devices. Now, this is excellent in terms of usability, as you can now use one credential across multiple devices and have them sync between each other. But remember the metadata we got from the authenticator on credential creation, which we could use to verify the security characteristics of the authenticator, which created the credential? Well, that doesn't make sense anymore, since any iOS device can now use any passkey created on any other iOS device connected to the same iCloud account. Actually, if you're doing syncable passkeys, it's the security characteristics of the device that uses the passkey that's interesting, not the device that created it. But in the FIDO2 specification, there's no attestation on use, meaning there is no signed statement on the security characteristics of the authenticator when you use the credential. That's only there when creating it. And you might have created the credential on a different device than you're using it from. So at this point, we're not getting attestations anymore. We had them, they released iOS beta, we realized we were going to lose them. A bit later, Google also started syncing passkeys, but they respected a credential creation option named Require Resident Key, which allows you to require that the credential should only be stored on the authenticator it's created on, effectively allowing you to opt out of having the credentials sync. iOS, on the other hand, ignores that option, meaning that on iOS, there is no way of opting out of syncing your FIDO2 credential to iCloud. In fact, I don't think you can even create a FIDO2 credential on the platform authenticator on iOS without first enabling iCloud sync. Now, at this point in time, we're due to launch in 2 weeks. What are we going to do? And you might be thinking, is this really such a big deal? Can't you just allow the credentials to sync or whatever? But the answer is unfortunately no. BankID is under very strict security requirements set by the banks who own us, and doing such a fundamental change to the security model of a new BankID product 2 weeks before launch, that just wasn't going to fly. It's one of the requirements, answering my question here, was that actually your BankID is supposed to be just on one device. So it shouldn't be copyable, which is one of the reasons this was such a big issue for us. All right, so instead of launching in 2 weeks, we had to postpone the launch and adapt. So with the security model we had operated under until this point, it was a private public key pair with an attestation. So could we create some other private public key pair we can get an attestation for, so that we can use that instead of the FIDO2 credential on iOS without having to rewrite our entire codebase? And it turned out that yes, we could, as long as we had a native iOS app, which we had. And in this app, we can natively create a new key pair in secure enclave, protecting it with biometrics. And we can actually get attestations for this key pair via the Apple App-Attest service. So now we have, again, an attested key pair, but it's only accessible from inside the native app. So whenever we want to use the key pair, we need to bring the user into the app. And in the app, we launch a web view. And in the web view, we inject a JavaScript binding to native code. And on iOS, instead of calling navigator credentials get from our JavaScript, we now call bis credentials get, which calls the native code. And this modified function call would then imitate the WebAuthn interface and allow us to authenticate using the key created by the native app. Of course, during sign-up on iOS, we would also need to call bis credentials create instead of navigator credentials create. Let me show what an authentication looks like using this approach. So say we want to log into a website and we start from a browser on an iPhone. We click the login with BankID button, which brings us to this new page. And here we're asked to continue in the app, and with a big button saying Open BankID app. Now, clicking this button opens the app and embeds the web page and shows us the context. And now confirming the context prompts us for biometrics, which accesses the key created by the native app, and we're automatically placed back into the browser where we came from, and we're done. We just successfully, partially emulated the WebAuthn interface and got almost the same user experience by adding just a single click, the Open an App button. So we consider this a success. So the surprise we got from Apple in late August that year ended up delaying us around 6 months, but we were able to launch in April the following year. And since then, we've now surpassed 3 million users. We're processing over 16 million transactions every month, and we're waiting, hopefully, for an extension to the FIDO2 API, which may allow us to move back to the browser on iOS at some point in the future. Okay, so this was kind of the main plot line in the story of Passwordless BankID, at least so far. But I want to touch on a couple of other smaller but still relevant issues when it comes to implementing and supporting passkeys in real life. For example, the case of the missing FIDO2 credential. So with passkeys, there's a situation that can happen where the user creates a FIDO2 credential, and then they remove their screen lock. And since there is now no mechanism to protect the FIDO2 credential, the authenticator destroys the key. Now, if you were to try to use the destroyed key, this should result in an error like so. Can't use passkey. To use passkey, make sure you have a screen lock set up. And it does. Makes sense. However, if you also perform a third step, which is actually adding a new screen lock, the issue is no longer that you are missing a screen lock. The issue is purely that your key is missing. So the error says that there aren't any passkeys available. Now, this makes total and complete sense, but users, they don't necessarily understand that removing and then adding back their screen lock results in their key being destroyed. So this is a thing to keep in mind with regards to passwords versus passkeys. There's another issue I also want to tell you about, and it's the case of the missing attestations too. So what happened here was that in March of 2024, FIDO2 credential creation started failing on Android, not on iOS like we saw with the iOS 16 beta, but on general availability Android. And when we looked into why, it became apparent that over the course of 3 days, 98% of all Android devices had stopped producing attestations on credential creation. So we no longer got signed statements on the security characteristics of the authenticator, and we could not accept these sign-up attempts because of our regulatory requirements. So we were naturally quite worried at this point, fearing a repeat of the Apple story, but this time after we had launched, like a potential disaster. Fortunately, this was not intentional by Google, and we were able to get in touch with some Google engineers, and within 9 days, they had fixed the underlying issue. And as you can see here, the occurrences of missing attestations on Android went down, eventually to 0, and all was well again, except for on Firefox Mobile. Now, this story isn't related to the last one, except that it only happens on Android, and it has to do with missing attestations. Wait, hold on. And boop, there we go. Okay. So it turns out that in the context of the WebAuthn API, Firefox is very keen on the privacy aspects. So you know that attestation, that sign statement on the security characteristics of the authenticator, that actually includes an identifier of the authenticator model. So it's not a uniquely identifying like serial number, it's just a model of the authenticator. For example, this is the ID of this authenticator model. So by requiring attestation on credential creation, I can learn the fact that the user is currently using this authenticator model, for example. Now, Firefox thinks that the user should be able to understand and actively consent to this information being shared with us. And that's why they have implemented a dialogue. Do you want to share extended information about your security key? Now, if you click proceed, you will share the attestation and all is well. We're happy. However, and this is kind of interesting, this screenshot here is from the desktop version of Firefox, not the mobile version. And there's a reason I chose the desktop one. And that reason is that this dialogue, it doesn't exist on Firefox Mobile. So then nonetheless, they require you to consent to allow sending out the attestation from the authenticator, but there is no dialogue, there is no button to click. They're missing a piece of the UI, so we don't get an attestation. So this means that you cannot sign up for BankID with biometrics from a custom tab powered by Firefox. You need to use something else like Chrome. You can, however, use an already created credential from Firefox Mobile, but you can't create it in Firefox Mobile, at least if you require attestations. So this is the bug, and the bug report has been open for 6 years. Oof, yeesh. Yeah, I'm not going to get into it, but yeah, I'm kind of frustrated. I'm a Firefox user myself. I'm very frustrated. So if you're an Android user and you wonder why we require Google Chrome to enroll into BankID with biometrics on Android, this is in large part why. Browsers other than Chrome tend not to work like we would want them to. But Google Chrome also has its fair share of weird behaviors with regards to WebAuthn and passkeys. So Google Password Managers comes bundled with Google Chrome. So if you have Chrome installed on your device, you also have Google Password Manager. And you can actually put passkeys inside Google Password Managers. right? And they will sync to your Google account if you're using a key creation option which allows that, which is fine. But did you know that Google Password Manager supports setting a passphrase in order to encrypt the local data in Google Password Manager? And after you've set this passphrase, that login session from entering your passphrase will expire if and when Google Chrome sync is enabled on a new device with the same Google account, and when a passphrase is enabled on any already synced device. So this just means that if you enable a passphrase for a Google Password Manager on a computer synced to your mobile device, that will make the passphrase session on your mobile device expire. Now, why am I talking about this? The reason why is that on Navigator's credentials get, so when we try to use a passkey, the browser doesn't necessarily know exactly which authenticator my passkey is on. So, and there could be multiple authenticators available at a time. So the browser may try different authenticators until it finds the right passkey, okay? And you can probably guess which authenticator Google Chrome checks first. It's, for some reason, it's Google Password Manager. Who'd have thunk? But your passphrase session, login session, right, from entering your passphrase, that has now expired. So now Google Chrome has 3 options. It can either prompt you for your passphrase, okay? Or it can proceed to the next available authenticator, for example, your operating system authenticator, right? Which in our case at least is where we know the key actually is. We know it's in the operating system authenticator, right? Or Google Chrome can just error when it encounters a locked Google Password Managers. Of course, they just error. And the error reads, the operation either timed out or was not allowed, which isn't very informative. It's a very generic error message that's also used for many other situations around WebAuthn, so in general, not very useful. So we actually spent quite a while trying to understand why we had only a handful of users who could never use their passkeys, no matter how many times they successfully signed up. And so this was why. And the thing is, not many people actually have a passphrase enabled in Google Password Manager. And some of those who did and contacted us didn't even remember having enabled passphrases in Google Password Manager. So many people were totally unaware, and so were we, honestly. Yeah. Fortunately, with the help of a technical member of the public, we were able to get some Android debug logs, so we can actually figure out what was going on, and we realized this was the situation and the reason for the errors. So now we're actively trying to get Google to fix this too, and I think that we just reached the correct person at a conference in Istanbul yesterday, actually. So I'm very hopeful this can be fixed sometime relatively soon. Yeah. And in the meantime, we've implemented an alternative enrollment flow to detect that this situation is happening during the enrollment. And if so, we show the user a guide to re-input the passphrase. Now, if you're curious, here are the steps to re-input the password. So you open Chrome on your device, you click the dots, you open Settings, you go into Google Password Manager, and then you enter your passphrase and you click Continue. Now, once you've done this, Chrome won't error when checking Google Password Manager. Chrome will figure out, no, the key isn't in Google Password Manager. Let's check other places. And it's going to go to the operating system authenticator. Hopefully your key is there. It will be. And all is well. Yeah. So I think we're going to summarize. So yeah, we think WebAuthn is a very cool technology. For the most part, it's user-friendly. It's phishing-resistant, and it's fast. And who doesn't love a good standards body? Am I right, people? Yeah. But on the downside, it's very hard often to get attestations, but you won't likely need attestations unless you're doing strong customer authentication in the context of PSD2 compliant payment systems or similar. So this likely isn't an obstacle for you. And as I've shown you, there's a bug in Google Password Manager. Yeah. And it's possible to say that this error not being discovered by anyone else than us is a sign that the ecosystem is still lacking some maturity. Maybe not too far out there to say. Also, many other password managers have started supporting passkeys, so it will be very interesting to see all the possible ways that can potentially break things, referring to that earlier question from over there. So, yeah, that's it. Thank you so much for listening.